In my part of the presentation, I would like to introduce to you guys concept of multiple regression and statistic associated with multiple regression. First and foremost, what is multiple regression? By definition, multiple regression involves a single dependent variable and two or more independent variables. The questions raised in the context of bivariate regression which was mentioned previously can also be answered through multiple regression by considering additional independent variables. Can variation in sales be explained in terms of variation in advertising expenditures, prices, and level of distribution? Can variation in market shares be accounted for by the size of the sales force, advertising expenditures, and sales promotion budgets? Are consumers' perceptions of quality determined by their perceptions of prices, brand image, and brand attributes? Additional questions can also be answered by multiple regression are: how much of the variation in sales can be explained by advertising expenditures, prices, and level of distribution? What is the contribution of advertising expenditures in explaining the variation in sales? When the levels of prices and distribution are controlled, what levels of sales may be expected, given the levels of advertising expenditures, prices, and level of distribution? And the general form of the multiple regression model is y equals b0 plus b1 by 1 plus b2 by 2 plus b3 by 3 plus bkxk plus e. In the model, y denoted for dependent variable, b denoted for independent variables, and x denoted for proportion or correlation between b and y. Now, we are moving to the statistics associated with multiple regression. Most of the statistics and statistical terms described under bivariate regression also apply to multiple regression. In addition, the following statistics are used. Adjusted R2. R2, coefficient of multiple determination, is adjusted for the number of independent variables and the sample size to account for diminishing returns. Coefficient of multiple determination, the strength of association in multiple regression, is measured by the square of the multiple correlation coefficient, R2, which is also called the coefficient of multiple determination. F-test. The F-test is used to test the null hypothesis that the coefficient of multiple determination in the population. The test statistic has an F distribution with K and N, K, 1, degrees of freedom. Partial F-test. The significance of a partial regression coefficient, by a xi may be tested using an incremental F statistic. The incremental F statistic is based on the increment and the explained sum of squares resulting from the addition of the independent variables I to the regression equation after all the other independent variables have been included. Partial regression coefficient. The partial regression coefficient, B1, denotes the change in the predicted value, y, per unit change in x1 when the other independent variables, x2 to xk, are held constant. In terms of how to conduct multiple regression analysis, the steps involved in conducting multiple regression analysis are similar to those for bivariate regression analysis. It focuses on partial regression coefficients, strength of association, significance testing, and examination of residuals. Partial regression coefficients. To understand the meaning of a partial regression coefficient, let us consider a case in which there are two independent variables, so that first, note that the relative magnitude of the partial regression coefficient of an independent variable is, in general, different from that of its bivariate regression coefficient. In other words, the partial regression coefficient, B1, will be different from the regression coefficient, B, obtained by regressing on the only x1. This happens because x1 and x2 are usually correlated. In bivariate regression, x2 was not considered, and any variation in y that was shared by x1 and x2 was attributed to x1. However, in the case of multiple independent variables, this is no longer true. Strength of association. The strength of the relationship stipulated by the regression equation can be determined by using appropriate measures of association. The total variation is decomposed as in the bivariate case. SS. Y equals SREG plus SIRS. Significance testing. Significance testing involves testing the significance of the overall regression equation as well as specific partial regression coefficients. The null hypothesis for the overall test is that the coefficient of multiple determination in the population, R2 pop is 0. H0, R2 pop 0. Examination of residuals. A residual is a difference between the observed value of y I and the value predicted by the regression equation. Y residuals are used in the calculation of several statistics associated with regression. In addition, scattergrams of the residuals, in which the residuals are plotted against the predicted values, y, time, or predictor variables, provide useful insights in examining the appropriateness of the underlying assumptions and regression model fitted.